we're doing something really different here. We're going to talk about solving equations. Now, remember when we had open sentences like 5 plus something equals 12? You want to make it into a true closed sentence. We're just calling that an equation now. An equation is actually the exact same thing as an open sentence. Instead of a box, we're putting a variable like x. So 5 plus x equals 12, when we say solve that equation, we want to find the value of x that makes this true. Now, in some of these you can just look at it and see. For example, in this one the answer is 7, right? X equals 7 makes it true. But in some of these you're not going to be able to, so we're going to learn some techniques to actually solve different types of equations. Anyway, on this one, what you can do, you can actually add, as you'll see in class, you can add the same number to both sides. It doesn't change the solution. And it turns out the number that you could add to both sides to find out what x is the opposite of this number 5. If you add negative 5 to this side and negative 5 to this side, it doesn't change the solution to the equation. Think of the equation like a balance. If you take 5 pounds off of each side, it's still in balance. Anyway, on the left side, when you add 5 plus negative 5, you just get x. And on the right side, when you add 12 plus negative 5, you get 7. That's the solution. And you can actually check the solution too. If you go back to the original equation, 5 plus something equals 12, you plug in 7, does it make it true? Yeah, it does. Anyway, the rule I just demonstrated is that whenever you have an equation, you'll see why this works in class, by the way. But whenever you have an equation and you want to and a number is being added to the variable, like x, you add the opposite of whatever is being added to the variable, and that's how you can solve the equation. It works when a number is being added to the variable. You see on this next one how negative 12 is being added? So what that rule says is if you want to solve the equation, you just add the opposite of whatever is being added. If negative 12 is being added, you add positive 12 to both sides. Again, think of the equation like a balance. So on the left side you just have w, and on the right side you have 22. Again, you can check if you go back to the original equation and you plug that number 22 in for w, is it true that negative 12 plus 22 equals 10? Yeah. So that's a nice little technique. Of course, some of the problems get sneakier, of course. Let's see. Y minus 13 equals negative 9. This is an equation, and to solve it means to find out what y has to be to make it true. If you first write this equation in additive form, you got y plus negative 13 equals negative 9. So what we're going to do is add the opposite of negative 13. We're going to add positive 13 to both sides. What is negative 9 plus 13? It's 4, isn't it? Again, you can check. If you go back to the original equation, if you plug in 4, is it true that 4 minus 13 is negative 9? Yeah. So it's true. Now, of course, they get trickier. With fractions, it works the same way. If we're trying to find the value of x that makes this true, let's first write it in additive form. So what number am I going to add to both sides? Well, since negative 1/2 is being added, I'm going to add positive 1/2 to both sides. See? On the left side, they cancel. You just get x. On the right side, you get 2/3 plus 1/2. You're going to have to get the LCD there, which is 6, isn't it? So multiply this on top and bottom by 2. This on top and bottom by 3. What do you get? 4, 6 plus 3, 6 is 7, 6, right? Okay, let's keep on going. Sometimes instead of a number added to your variable, you may have a number multiplying your variable. And it turns out you could multiply both sides by whatever you want. The real question is, what is the smart number to multiply by? And it turns out, as you'll see in class, to solve an equation of this type, multiply both sides by the reciprocal of whatever number is multiplying your variable. We call this number, by the way, the coefficient. I don't know if you've ever heard that term before. 3 is the coefficient of this term because 3 is multiplying w. Alright, so what this says is multiply by the reciprocal of that number on both sides. So what does that mean? If the coefficient is 3, we multiply both sides by 1/3, like this. Now you got to be a little tricky. You got to be careful here. When you multiply by 1/3, this is really 3w over 1. So don't the 3's cancel? 3 times w over 3, you just get w. And here you get 21 over 3, which you could 21 over 3 is just 7. And by the way, you could check if you plug in 7 into the original equation, does it make it true? Yeah. So remember, if a number is multiplying the variable, you multiply by the reciprocal. The coefficient of x here is 5. So what we're going to do is we're going to multiply both sides by the reciprocal of that number, which is 1/5. Now, it might help to think of this as 5x over 1. Anyway, so the 5's cancel. You just have x. Here you have 7 over 1 times 1/5, which is 7/5. Again, if you wanted to, you could check. Plug in 7/5. Is it true that 5 times 7/5 equals 7? Yeah, the 5's cancel. Sure enough. Now, as some of you maybe noticed, I get this in class a lot. Students might say, isn't it easier, instead of multiplying by 1/5, isn't it easier to just divide both sides by 5? And the answer is, they're the same exact thing. Those are really the same thing. There are some times when it might be easier to write it that way, but there's sometimes when it isn't. In this case, instead of multiplying by 1/5, you could have also written it like this. Divide this side by 5, divide this side by 5. Because dividing by 5 is exactly the same thing as multiplying by 1/5. So on the left side you have x, on the right side you have 7/5. Now here's a good example where it isn't a good idea to divide, just where you really can't think of it as dividing. Let's think of it as multiplying by the reciprocal. The coefficient that's multiplying x is 3/4. So what are we going to multiply by? The reciprocal of 3/4 is 4/3. Think of this as 6 over 1. So on the left side, notice the 3's cancel and the 4's cancel, so you just have x. On the right side, we can factor everything. Cancel a 3. Final answer is 8. Alright, let's see. Let's do a few more. We're going to multiply both sides. Since 2/3 is multiplying w, we're going to multiply both sides by the reciprocal, which is 3/2. So on the left side, everything cancels except the w, and on the right side, let's start to factor. And you can cancel a factor of 2, I believe. Final answer is 27. How about this? Negative x equals 5. Now, be careful here. Negative x means negative 1 times x. So the coefficient of x is negative 1. So you could think of it as several things. One way is to just think of it as dividing both sides by negative 1. That would work. In which case, the negative 1's cancel. You have 5 over negative 1, which is the same thing as negative 5. Okay, how about this one? Remember, the coefficient of y, that means the number that's multiplying y, is actually negative 1/3 here. So we're going to multiply both sides by negative 3 over 1. And then when you factor the right side, I think you can cancel a 3, right? So your answer is 5 over negative 3, which is negative 5/3. Okay, I'll give you something to try in a minute, but look at the difference between these two problems, okay? The first one, something's added to your variable, so you're going to add the opposite of 3/2 to both sides. In which case, on the left side you just have x. On the right side you have 1/4 plus negative 3/2. Common denominator is 2, so you get 1/4 plus negative 6/4 is negative 5/4. But on the right side the number is multiplying your variable. What do you do when a number is multiplying your variable? You multiply by the reciprocal. So here you'd multiply by the number 2/3. And then on the left side you just have x, because everything cancels except the x. On the right side you factor. Final answer 1/6. Alright, well let's see. Why don't you hit the pause button. Try these, we'll go over them in just a minute. So look at these first two. Don't get it confused. When a number is multiplying your variable, you multiply by the reciprocal. In this case, you could also think of it as divide by negative 5. So the answer should be, you should have gotten negative 7/5. On the second one, since something's added to your variable, you add the opposite. So we're going to add positive 23 to both sides. So you get 63. On this one, since something's added to your variable, you're going to add the opposite, which is negative 2/3 to both sides. On the left side, you just have x. On the right side, you got to get the common denominator. Multiply top and bottom by 2. What's 5/6 plus negative 4/6? 1/6. Last one, something's multiplying your variable. Multiply by the reciprocal. 3/2 on this side, 3/2 on this side. Factor the right side. I get 5/4. All right, we'll see you later. Bye-bye.